Everyone, please welcome Dragan Stefanov, our next speaker.
Hi, everyone. My name is Dragan, and I'm going to talk to you about serverless today. I don't know, I just realized actually that the name of my talk sounds like some kind of bug, so I don't know how many of you actually realized that we are going to talk about serverless. Just before we begin, I would like to just see a show of hands, like to see how many people actually know about serverless here. Oh, that's great. Sounds awesome. So a few things about myself. I'm CTO of Digidip. It's a startup in Berlin, and previously I worked for Holiday Pirates. And in a previous life, I was also founded Mars, basically of this project that I started with my colleague in Belgrade while I was still studying. So plan for today is actually to try to define what serverless is, to see how it works underneath, to understand why we would use something like that, and in the end actually to address some of the concerns that might come up with usage of this quite interesting technology. So basically, a serverless is abstraction on top of abstraction, right? There are a lot of things labeled now these days as serverless, but the main thing that kind of connects all of these notions is the fact that those services are managed by a third-party provider. So you as a developer or as a business operator, you don't have to think about scaling infrastructure and monitoring, or basically you just kind of leave that to the third party to do. And as a result, you can be more productive, and this whole model also has like really interesting payment component where you pay only for usage. So basically you never pay for some idle time. So if we look at the kind of more from a pure definition of what serverless is, it basically replaces the long-running virtual machines with ephemeral compute power that comes into existence and basically disappears when the job is done, right? That's the kind of innovation here. So we have this compute power comes up and then just disappears. So there is no running server. You're not paying for a server. But still, we have server underneath everything. So you just don't have to worry too much about it. We have basically two types of serverless services, let's say. So we have a function as a service, which works in a very simple way. So you write the function, you give it to the engine executes it, and that's it. Basically, these functions usually react to some kind of trigger that could come as a HTTP request, or new message in a queue, or basically new file is in a bucket or something similar. And what's very important is that the unit of deployment is just a function, so not the whole application, not the app. A second type of serverless is actually backend as a service, which is usually, again, completely managed by the third party. You pay as you go on demand, and those things include databases like DynamoDB, Firebase, and authentication services like Auth0, or storage S3. So if we look at those two things and try to compare them, so on one hand you have Amazon Simple Storage Service, or S3. It works very simple. I think Nicola already mentioned that it's basically very, very dumb in a way. You just give it an object and it stores it. And you really don't know where. You don't know which server it's going to be, and you don't really have to care. You just know that it's going to be there. Same thing with Amazon Lambda. You have you write the function, you give it, and you don't know when it's actually going to be when this function is going to be executed. You simply just don't have to worry about it. You cannot actually under-provision or over-provision these services. It's simply not possible. So when you're planning capacity, you can simply just call the function and that's it. Like, you don't have to worry if like there is enough power behind, there is not enough CPU or memory. So I used Amazon Lambda and some other Amazon services, but Lambda is not the only kind of player in town, right? So we have all the major cloud providers in this game. So we have Google with cloud functions. We have Azure. We have Oracle in there. We have some open source solutions. Oracle is the latest, I think, latest player that's getting into this game. Oracle has been behind the FN project for a while, and now I think soon they're going to announce their Oracle functions. So just like a really strong signal from a really big company coming into this space. I think it kind of shows that how serious it's not only hype, but it really becomes like a very serious thing. In this slide, we have basically how that whole magic works underneath. Like when you think about it, you just give it a function and it executes it, and it just kind of shuts it down. So, but you have to understand that actually, like I said, it's just abstraction on top of existing abstractions. So you have like your physical machines, you have like your virtual machines, and then you have Docker, you still have schedulers, and all of other things that are kind of already known. So as you can see here, this is a open source, this is kind of architecture of one of the open source solutions, functions and service solutions. You can see that basically Docker, like containers, are all the way. So now when we talk about developer's experience, I really want to show you a little demo. I pre-recorded this. I have here on my machine set up a FN project, which is still open source, but it's going to be supported by Oracle functions. So I want to show you how that looks like for a typical developer. So we starting by initializing function, and we give it a runtime. So we can pick, I've picked here node, and I'm going to give a function name. Basically, we get generated some boilerplate, and we are going to now edit the function that's been generated by FN command line. So as you can see, it's a really simple function. Like I said, we picked Node.js here, but most of the providers support other languages like Go, Java, C#, Python. Those languages are almost supported almost with every provider. This is Node.js example. We're just importing function. We're importing function development kit, and basically we have just a little handler there, and inside is a code that we can write and basically customize the way we want. So as you can see, there's not like a lot of additional stuff that you need to do. It's basically you're just writing a function. I kind of slow typer here. I couldn't speed up this. And when you're happy with your function, you can then just try to deploy it. So like I said before, basically unit of deployment is function, is not the application. We are going to deploy this, this function inside the namespace growIT as a demo. So we're going to now build a container. So basically we build a container for this function, exactly. And then we are just going to try to invoke the function very simply. And to give it a namespace, and I'm just going to give it the name of a function. And that's it. So we get our response immediately. Basically, we just run the function and shut down the container. So just to recap, basically how it works, you initialize with the runtime of your choosing. You can also specify if you want to trigger, if you want to use a certain trigger. So in this case, in this example, I have HTTP trigger. So it means that this function will be invoked when actually HTTP request comes in. Then you edit your function and basically deploy it. So you can see at the last line, you can see that trigger endpoint is available. So you can actually call this address and trigger the function. This is all very nice and great, but naturally, this is not how real world looks like, right? Like examples in real world, usually not hello world examples. So what I wanted here to do is try to show you how actually production-ready hello world example looks like. So yeah. In this case, we have a Go application that was written for Google Functions. And this is just the beginning of the, let's say, beginning of the function, beginning of the program. We are just doing some imports, and if you pay attention, you can really see why is this production example, because we are importing a lot of logging and tracing tools in the beginning. Then we are having, here we have our main function, and as you can see, most of it is taken by most of the space is taken by setting up logger and tracing. And then in the end, we are just like writing hello world, right? And if you look at this private function here that is called by the main function, you can see that a lot of stuff is still going on. Like we are still setting up, like loading a lot of environmental variables, setting a lot of other things. So this would be basically example, how would you actually write? So it's not like 3 lines and you're done. It's actually like doing a lot of preparation actually before you can invoke a function. And I really want to stay kind of in this real world example realm. So I want to tell you a little bit about experience with my company, company that I work for. We had a week ago, we had Black Friday, which is like the most important day in the year for us, because we're basically like a sub-network or affiliate gateway. So we connect to a lot of publishers, to a lot of different affiliate networks, and that all goes through our system. So on Black Friday, it can get like really tricky. We can get a lot of unpredictable amount of traffic. So having like a really rigid infrastructure that cannot really scale easily, it's really kind of nightmare-inducing. It's a big problem for us. So basically, this year we started on a journey, on a serverless journey. So we wanted actually to prepare for this year and make our infrastructure much more flexible. So this is how currently our infrastructure looks like. We started as a completely inflexible, and last year was pretty horrible. And that's why this year we started doing like a lot of serverless stuff. And as you can see, we still have to provision certain servers, but we are more and more relying on Amazon services like Kinesis to ingest data, Lambda to ship and transform data and push it into Elasticsearch. We store a lot of data for safekeeping in S3, and then we would push that data onto our other systems. So basically, this made the whole system much more stable compared to the last year. We didn't have any downtime this year, and basically data delivery had like really minimal delays. Like I said, we are just started on this journey, and there is so much more we can do. There are like a lot of long, low-hanging fruits that we could just pick. And for example, for me, it would be really great if these click servers that you see here, if you have right now 10, that are running PHP application with MySQL, if you can just replace that with one, let's say, node function, that would be really nice. If you're interested in more kind of real-life examples and reference architectures, Amazon has put out something called a simple beer service. So they have like a little Internet of Things devices they're putting on a kegs. So every time that keg is used, basically amount of beer flow or temperature or humidity is sent to this central service, and you can see like a little dashboard from every country how much beer actually everyone drinks. And it's really good reference architecture for this thing. So so far we basically defined like what serverless is. We looked at like different types. We basically looked at kind of real-life examples and also like real-life architecture. And I'm now like really just want to address a couple of concerns. Since basically there is no way to SSH into a machine and look around, it gets a little bit tricky. So you have to really instrument your function very well. So like we saw in the example before, you have to set up tracing. A very common pattern is that you would see that function calls another function and that function calls another function. So you can rely maybe on logs that providers give you, but really to correlate those logs is really, really difficult. So you have to do the tracing. So you have to use tools like OpenTrace, and then maybe ship that to Zipkin or Jaeger or something like that. So this becomes like really, really important. And it's possible to solve, but you can see that it adds a little bit more complexity. Another concern is basically performance, because like we saw before, underneath that we still have containers. So every time you would actually, if you don't use your function, you need to kind of spin up the container. It takes definitely some time. And because functions are, you're paying them by the milliseconds you use. So if you have this container that needs to spins up and you need like a couple of seconds, you're paying for something that you really don't use. So it's really not optimal. And that's called cold start. So providers are coming up with like a lot of solutions how to kind of alleviate this. But you can also do the same, very similar things, for example, using common pattern or just like setting up a schedule to kind of keep your function alive, kind of keep it still hot. Some other providers, for example, like Cloudflare, they came up with like really, really interesting solution that is completely different. It doesn't rely on containers at all. It uses a V8 JavaScript engine. It's really, really crazy fast and it's very isolated and secure. Only downside is that you can just use JavaScript but not JS. You cannot use other languages, of course. Just a couple of days ago, there was a reInvent in Las Vegas where Amazon was showcasing like their new offering, and they announced Firecracker, which is their open source micro VM based on KVM virtualization, which has a really, really is a really, really promising technology with a really small footprint. So this is the technology that can really kind of make this problem with cold start disappear. Of course, security, very important. There's a saying that friends don't let friends run unsecure containers, right? Like you saw, again, the containers are underneath in most of the cases, so that could pose a problem. And again, providers are really working on it, just making better sandboxing, using like something new like Firecracker could really help with this. Another big one is capacity mismatch. So basically, whole promise of serverless is like effortless scalability. So you give it a function and it runs it like a million times, right? But what if that function calls like a system that's actually not scalable? What if your database is not scalable? So you basically have this capacity mismatch, and that just won't work. You're just going to kill because there's no connection pool management. Like your function is just hitting your database. There's no like any kind of queue. So you have to be like really mindful about that. One of the solutions could be actually just to use other serverless solutions, like backend as a service. Like you could use database that's serverless that can scale easily, effortlessly, like DynamoDB or S3 or stuff like that. But in general, you have to be like very mindful about like what are you using, what are your functions are going to call, which services. And one last concern is basically vendor lock-in. So if you start using, for example, Amazon Lambda, a lot of people are afraid it's going to be too dependent on Amazon itself. But it's not a problem, really, because like you're writing a function that has like a minimal boilerplate. So like you can always like port your functions. But if you start depending on other services, like and you really enjoy, like you're very comfortable in Amazon and you start using S3 and SQS and SNS and all the services, then if you want to like port and move, that's a really problem. So maybe this is just kind of gateway drug, but you have to be mindful about this. There is also a choice. You can use open source implementations, and then You can use open source implementation of function as a service, and then, like Nicola mentioned, you can use something like Minio, which is open source implementation of object storage. So you can still like use this kind of thing, but just kind of be more mindful and use maybe open source and not really rely too much on providers. But that's also a trap, because you really don't want to get into this Andy pattern when you have like very serverful serverless, where you actually still again like manage all the servers, and that kind of beats the point of the whole thing. So if you're still not convinced, please go to this website I just created last night in my hotel room. It's completely serverless. I just made it like to encourage everyone to just kind of give it a try, and there are like few resources that I used to kind of prepare this talk. And yeah, I just hope like you will check it out. And basically that's it. Thank you. So, questions? All right.
Is there a way to kind of pace functions as a service? For example, one function calls 50 others, and those 50 others call 50 others, and then it kind of cascades out of control. So, and each function will cost some kind of money.
Yes,
and
absolutely.
And you know, if you fold a piece of paper like 100 times, you'll reach the moon. So, how to prevent these kind of cost overruns?
Yeah, you definitely have to be mindful about this, because if build can actually like spun out of control. Definitely, you have to be mindful about like how many calls your functions are making, so you kind of avoid this kind of cascading. You definitely have to use something like tracing to see how this kind of graph looks like, right? Because like if you don't really pay attention and you start calling this like large amount of functions, yeah, maybe you will not notice it, but like you will notice the end of month when the bill from AWS comes, and you'll be like very shocked. So using definitely tracing tools is a really good idea. So you can definitely kind of visualize what you have as a usage.
About the cold start thing. It wasn't really clear to me how using command pattern would solve that issue.
So basically, when you use command pattern, you would have like entry point for your kind of call lambda. Like if you have like more functions, right? And that's a common pattern. You would use command as a kind of gateway, right? Like to call like other functions, right? Kind of just shift. And then that also purpose of that function would be actually to kind of keep the rest of the functions kind of alive. It's also like in a way of a scheduler. Yeah.
Okay.
But providers are getting much better in this, so it's not like really that big of an issue.
Okay, so command pattern is like a temporary. We won't.
It's a good pattern
do like
for
Firecracker instead.
Yeah, it's a good pattern actually for development. Because I mean, you would have like a lot of functions, right? Like in a real life system. So, if, for example, if you want to have like serverless CMS, like there would be like a lot of functions, but you need to kind of find a way how to kind of group them in an efficient way, right? So, command pattern is still a good idea. Before it was more also very useful for keeping it up and hot, but now it's not like really that big deal. Yeah.
Thanks.
Philosophical question, don't worry. Okay, so just looking at the example, one is Node.js, the other one is Go. Do you think this is going to make a push for functional programming as a old new paradigm? Do you think this is going to change from object-oriented?
Yeah, definitely. So there's no shared state, you know, and basically they're not classes. You have just functions, and the function is called another function. So you rarely have side effects. So definitely, it's kind of bye-bye to object-oriented programming. Yeah.
What about price? Can you compare
Price.
maybe to last year? Because last year you were not running the lambdas.
Yeah.
Functionless.
Basically, I cannot like uncover like how much we pay. Definitely, it's not a big issue. Lambda itself is not really expensive. The only problem is like what you put like in front and how do you use them. For example, if you expose Lambda directly to the outside internet, so like let's say you have to use like HTTP as a trigger, you have to put something which is like API gateway to kind of call those Lambdas, and that that gateway is very expensive. That's the problem. But like Lambdas on their own are not. Like they react to some kind of system inside. Let's say if they react to the messages, if they react to like things like objects being put in S3, they're just it's not really a big deal. It's just like depends like what's the entry point into the system. And so far, it was only possible to get into to use HTTP trigger just with API gateway. But now, I think like a couple of days ago, they announced that you could use application load balancer to trigger the function. So which should be like enormous kind of cost saver. So it's not a big deal at all.
So you didn't get the end of the month bill for the website?
No, I'm not worried at all. We did test before, so just to be sure. Yeah. All right, any other questions? All right, thanks a lot.